I hope you had a wonderful lunch, and I'm assuming that you guys not feeling, sleepy. The thing that I'm talking about is because the topic that I'm bringing today is kind of interesting, as you know. It's just like, can internet function without internet, right? I mean, the question itself curious, right? So today in this talk, we kind of explore if it is possible, and if it is possible, then how, and if not, then why not, right? So recently I was thinking that why do we take it as a granted? Like, for example, if internet, let's say internet goes off for some time, right? We just as a people take it as a granted. Let's say, okay, internet goes off, it will be, let's say, back in some time, in few minutes, right? Maybe even an hour, and we just don't care about it. What if it's something serious, right? So in this particular thing, for example, in this same thing happened recently in 2019 in Taiwan. There was the same incident happened where internet is kind of plugged off for whole 7 days. Are we prepared for that situation? I mean, today not, maybe, right? So today we'll be figuring out the answer of our question: can internet function without internet? Right? So the answer is yes, it's already possible. So it's like a puzzle where we need to figure out a few pieces and arrange them in a certain way that allow us to make it work. So that is it. So before going into talk, let me introduce myself. I am Samarth. I am currently a software engineer at a company called Data Genie, and I have been involved in this open source industry since last few years. And so yeah, let's get into it. Okay, here's the question. Can internet function without internet? So in today's world, we kind of rely on internet for almost everything. Like, even for a smaller thing, we are kind of dependent on it, right? But what happens if it's not available? See? So let's try to explore some, decentralized offline capable web applications that allow us to stay connected even when our traditional application goes fail, right? So in today's scenario, what is the fragility of our, current global connections? For example, let's say, picture this. You are doing something, you are messaging your loved ones, you are committing something, you are pushing your code to the internet, and internet goes down, right? What will you do in that particular situation? I mean, we are not certainly prepared for this kind of situation. So the problem could have happened like, it could be like communication breakdowns where it says connection is lost. It could have happened like work collaboration halts, access denied and all. And if we're trying to reach our server, it will say information disappear, 404 not found, something like that, right? So this is the thing. And even the bigger question is, what if it never came back? That itself sound very, disturbing. But the twist is we can still able to build a web without it. So let's try to see how we can build a resilient internetless web. So basically, let's say internet is down. Does that mean everything stops? Well, not really, because our devices, let's say your laptop, your mobile phone, doesn't actually need internet in order to stay connected. It's like they are built and designed in a certain way that do not requires any internet to functions. For example, let's say instance of Bluetooth, right? It doesn't require internet in order to stay connected with any another device. So it's just that we never paid attention to it. It's like we are kind of in a chains of that, but it can still be survivable. So as a part of puzzle, here's the first piece that came. That's called mesh networking. So what is mesh networking? Mesh networking, consider it as a, let's say there's some multiple nodes in a network. Each node can, connect as a, peer-to-peer, as in each node can act as a server and act as a client itself. So the tagline would be it's like no ISPs, it's just us. If there are some certain people present in a room, we actually don't need that part. Our devices can use the technology of hopping mechanisms in order to transfer the data or maybe communicate with each other. So for example, let's say assume it like how ants communicate. So let's say there is a colony of ant, right? How ants communicate with each other? It's like message passing. So they'll pass a message from one ant to another, then to another, then to another. So it's like hopping mechanism. For example, in here, there are some certain nodes. Let's say we want, communication between A to E. It would be like A to D, D to E, and etc. For example, for H, it will be like F to G, G to H, etc. So it's only the demo purpose, right? Now, let's say our mesh network is up and running. Our devices can, talk to each other. But what about our apps? Because, we are not satisfied with only our devices stay connected. Our apps does require actually internet in order to function, right? So let's say if internet goes off, our application would behave like a spoiled children. It would be like, hey man, why did you just cut off the internet? I won't work. So it's something like that. So for that, we have the next solution that that is called offline first web applications. So what is this offline first web apps? So it's basically something. It's based on the philosophy that if we design application as it will be always offline, but it will be treat online as a nice to have. So that's the philosophy behind it. Now there are three principles that come into existence in this offline first web application. Those are service workers, IndexedDB's local storage, and progressive web apps. So what is service worker? Service workers you can consider it as a programmable proxies that basically intercept your request, basically cache your data onto the local, and it has even the capabilities to cache your whole application into the local for some instances. Then let's say that part is done, we come to IndexedDBs and local storage. So IndexedDBs and local storage are kind of a thing that it's kind of a key value pairs, key value storage mechanisms, which allows us to persist our data even when there's no medium. So consider it as your local mini backend at your own laptop or on your devices. The third part, that is called progressive web apps. The progressive web apps is basically with the help of some certain manifest files, some YAML files, and some plugins, we can able to make our existing application downloadable and use it offline wherever we want, regardless of connectivity. So this is the progressive web apps. Even I have prepared one demo in which we have used this progressive web application, and one more thing that allow us to show you how it can work in a real time. Now let's say our mesh network is up and running. Our devices can talk to each other. Our application stays offline, can work offline. But what about our data? I mean, let's say I want to send data to my friend, receive something from him. It requires server. It requires internet in order to do that, right? In the current scenario. But what if we see like we doesn't even require server in order to do that? The thing is, here comes the third piece of puzzle that is called IPFS. IPFS is basically interplanetary file system. So it's a way of storing our data in a certain way. For example, in current scenario, how IPFS would work. IPFS is something that instead of file being located by where they are, it will store based on what they are. It's like cryptographic hash. So for example, in here, if you see, this is a traditional web applications where where any file would be stored based on the location, like server.com and file.jpg, right? But in a decentralized web, in IPFS, it would be stored like with the help of their cryptographic hash, like what they are instead of where they are. It will be stored based on that. So, I mean, it's really sound like a sci-fi, but it's already possible. We have some real-world example, like Filecoin, DBWeb, etc., which are using that part. Now, okay, our mesh network is up and running. Devices can talk to each other. Application can stay offline. We can, send data to one another, send and receive data. But let's say two people or two users want to, have communication with each other at the real time. As in, let's say you are editing something, your friend is also editing something on a similar board, something like Google Docs or something, right? In that way, how the sync would happen? Because since we are talking about there's no internet, there's no sync in between, but let's say user A is editing something, user B is editing something. And when the internet goes back, or maybe, there's a sync in between, there could be problem happen like, merge conflict, merge hell, etc. There could be a lot of problem with that. For that, the third piece of puzzle that is a very important one called CRDTs. CRDTs is basically conflict-free replicated data types. You can consider it as a data structure that allow us to update the data independently on all the replicas. So it will be like changes are in sync in any order at any time. The result will eventually be consistent without no conflict. Even in our demo part, we have used this particular technology in order to achieve that. So how CRDTs would work? So CRDTs are generally based upon two types. There's a state-based CRDTs and operation-based CRDTs. So for example, in here, there's two things. Let's say user A is typing something hello and user B is typing world. Now, whenever we do sync changes, what a real CRDT would have done is it will take a hello from user A and a world from user B and intelligently merge it with the things like hello world. But in a real world, thing could have gone wrong. For example, if merge happen, how does it know that hello should go first and world should go second? I mean, world should go first and hello would be second. How it is defining that? So it's based upon how our CRDTs would intelligently figure out that. So this is the last piece of puzzle that allow us to do that. Now, the best part is let's try to see it in action. How we can achieve that. So in our demo applications, we have used two technologies. One is progressive web applications that allow our application to stay offline and work. And second is our CRDTs, right? Out of this 4 piece of puzzle, we have used 2 and kind of demonstrating that. So for example, here if you see, there's an application called SyncPad. It basically the application which is which can work offline and based upon the CRDTs. For example, let's say I have opened this particular application on my laptop and also this particular application on my phone, right? Now, if you see, like since we have the internet right now, it says we have one connected devices, right? Let's say if I type something in here, let's say if I type something on my mobile phone, it would be on a real time present in here, right? But we are not talking about this, right? We are talking about what if internet is not there, right? So let's say we just turn off the internet for now, and then try to type it in here. On my phone, I have typed hello. On laptop, let me type world. Now, when this internet goes back, it could have behaved like world could be the first word and hello could be the second word, right? But it will eventually intelligently manage that world would be the second and the hello would be the first one. It is based upon the local indexing part. Local indexing as in the local index DBs that we discussed, right? So since we have the internet right now, let me refresh it once. If we have it, yeah, you see, it's just connected with this particular device and it says hello from mobile and world from here. So this is how easy it is. It's like intelligently kind of manages and detect with the help of CRDTs and local index DBs how our data should be in sync, even when there's no internet at all. But you would ask me, hey Samarth, you just use the internet in order to connect both the devices, right? But the thing is, I told you, like we are using 2 principles out of 4. That is PWA, that is Progressive Web App. I just use this application offline in front of you, and we are using the CRDTs that allows them to merge, intelligently. So those are 2 principles which we have used in here. So now coming to the verdict, can internet function without internet? The answer is yes, but maybe not everywhere yet. But enough to survive in a moments wherever we need it, right? So most importantly, I would try to say that it's time to stop thinking about offline as a fallback only, right? And it's time to see that we can do it as a foundation level. Why can't we make it on a mainstream instead of as a backup only? So this is the talk is about. Thank you for having me, and looking forward to catch up with you all. And if you have any question, looking forward to connect with you on LinkedIn and like after this talk, we can do that. The reason is because we have another talk after this, so let's not try to waste the time. So that's it. Thank you for having me.